Well, hey there, and welcome to yet another one of my cheesy YouTube videos. Today's video, I'm going to repack the steering cylinder on my little old John Deere 401D. We'll talk a little bit about hydraulics and seals while we're doing it. So let's get started. Before you take apart any hydraulic cylinder, you want to make sure that there's no load on it. For me, I'll just wiggle the rod around. If I got play, then I know there's no load on the hydraulic cylinder, because if you take it apart, the load on it, you're liable to hurt yourself. Another thing you want to do when working with hydraulics is have a clean work area. So I'm going to try to clean this up a little bit before I take it apart, so we don't introduce any dirt into the system, because the pump and the valves work off extremely close tolerances. This bolt is actually working as my set screw. I bought new set screws I'll put in when I go back with it, but that bolt's been doing the job for quite some time. You can usually repack a hydraulic cylinder leaving it in place except for taking one pin out. But the first thing I'm going to do is I'm going to at least undo my lines and not necessarily have to take them off, but back them off to let air pass through. Get a little exchange of air going on in there. I'm going to leave that back line hooked up for now. It may or may not come out with that back line hooked up, because there's probably going to be a suction on the back side of that piston, which is inside here. But instead of crawling underneath there, I'm going to try not to have to undo it. So I'm going to pull the pin off the front of the cylinder. Well, before I pull it off, I'm going to put a spanner, which this spanner's too big, but I'm going to get another one, or some sort of wrench, and I'm going to undo this, what they call the gland. The gland is a part of the cylinder where the rod passes in and out of. Actually, this rod's in terrible shape. Look at that. Crud. The chrome is gone. So even though I'm going to repack it, it's still going to want to leak as it passes through there. I'm not sure what happened to that rod, but it's in terrible shape. So, but anyways, we're going to pack it anyways. I got some dirt I got to move today. But this is the gland. It supports the rod seal and the wiper seal. The wiper seal is the outermost seal. It's not really a seal, it's a wiper. And what it does, it protects, it wipes off the dirt and grime off of the rod as it sucks up into the cylinder. And then the rod seal is right behind it. And in this case, it's what they call a U-cup. Let me go ahead and pull this apart. I'll put a spanner on here and I'll unscrew this. But also let me say that whenever you got this kind of nut, some sort of gland that screws in, look for a set screw. Sometimes the set screw's covered in paint and you may not see it, but there's almost always a set screw. You could be wrenching on this gland, saying, man, this sucker is snug. And it turns out you've wiped all the threads out as you screwed the threads past the set screw. So look for that set screw and get it out of there. Also, you may not necessarily have this type of gland nut. There's all sorts of configurations. This one's got internal threads inside the cylinder. There's some that have external threads and the gland goes over the outside. And there's some that are called tie rod cylinders, which you'll see all the time at the tractor stores, which have 4 tie rods, and the tie rods draw tight, draw the barrel, the bottom and the top ends together and holds it together that way. There are some that you'll find a cutout in the barrel, and in that cutout's a little square ring that goes around, and there's a groove cut in the gland and a matching groove cut into the barrel, and there's a hole drilled into the groove of the gland that this ring will lock into, and then you turn the gland and it draws the square ring into the cylinder between the gland and the barrel, and that's what keeps that gland from pushing out. It's important that if you got that kind to know that you've got it, and don't go turning on the gland, not realizing that you had that type of configuration, because sometimes that square ring can get caught up in there and wind up just traveling around in the groove. Then you have to try to find the end, bend it, and get it up. But usually that end is curved a little bit into the barrel, the notch in the barrel, to where that won't happen. But it definitely can give you a problem if you're not careful with it. So that's yet another way that these things go together. Some of them you have to drive, there'll be an outer snap ring that you pull off, which allows you to drive the gland into the barrel, then undo an inner snap ring, then pull it apart. There's a bunch of ways hydraulic cylinders come apart. So my point here is, please study up on what you've got before you go tearing into it, because you may actually cause yourself more problems. I got the gland loose. I didn't have a spanner to fit, and even if I did, it wouldn't have initially broke it loose because it was super tight. I wound up using a pretty stout chisel and a hammer and just gave it some blows to knock it loose. Before I did, I scribed a line between the barrel and the gland. That way I can at least see if the gland's moving. Then underneath the pin here was a cotter key, and I pulled the cotter key. And here's the pin. So now the gland's got to come out. We'll use channel locks. And just in case you're wondering, the channel lock brand of channel locks I find to be the best ones out there. Till you busted your knuckles enough times, you'll learn not to buy junk when it comes to that. Should be about out. There it goes. This is the gland. It's kind of filthy inside. See if that rod will come out. See, it's pulling a suction, but I was able to bust the suction loose. So next thing I'm going to do is I'm going to pin this rod back into its place so I can put a wrench on the nut at the end of the rod. Pull the piston. This is the piston. I'll pull the piston out. Then I'm going to pull the gland out. Then I'm going to pack everything. Okay, I got the nut off. Piston should slide off. If not, take a hammer. Yeah, some people tell me not to do this, but I just kind of slide down the rod gently. Tap it back on. This ain't right. Whatever's in there, it's catching on them threads. I think I'm going to have to put channel locks on here and try to turn it, which means I'm going to wind up putting grooves in my piston. This is the gland. This is the piston. So whatever hung me up was probably this chrome flaking off, getting hung up in there. Now, I said I'm not going to replace this seal, and I'm still not going to replace this seal. This is the piston seal. This seal is not picking up a load. All this is doing is turning the tractor. But even if it was picking up a load, if I examine this seal and it's not gouged or in bad shape, I don't like replacing them. The reason being, this is like Teflon or something. And it's got a couple of scratches right there, but I'm still not replacing it, especially since it's not picking up a load. And it steers easy. Tractor steers easy. But the reason why is the new seal, you have to stretch it to get it over the edge here. And when you stretch it even a little bit, it stays stretched for a good while. If I don't have to replace these, I don't. Because by the time you stretch them, sometimes you can put a hose clamp on there and tighten the hose clamp down, let it sit for a while, or you can just leave her be for a while, and usually they'll kind of shrink back into place. But if you're not real careful, you could damage it permanently. So I do got a few marks on here from my channel locks. I need to take some memory cloth or something and dress it up. Okay, let's talk about seals. First of all, this is the wiper. It's usually metal clad on the outside. In this case, now there's some wipers that just pop in like a seal, so I usually put a screwdriver behind there and give it a few taps, then twist it. It's on its way out. This is that Teflon piston seal that I was telling you about. Under it should be an O-ring or something like this. It's feels hard to the touch, and when you stretch it to go over the piston, you have to stretch it quite a bit, and it doesn't like to stretch, and does not like to stretch back. So that's why, if I don't have to, I will leave the piston seal as is. Then this is the seal that seals the rod to the gland. This is called a U-cup. There are different types of U-cups. This is a rod seal. The rod seal will have a flared lip on the inside, which rubs against the rod. Got a groove on the back. It's opened up on the back. Pressure, hydraulic pressure gets in, and it also forces the seal into place and makes it seal better. Rod seals don't have much of a flare on the outside. You don't have to go buy these seals to fit the application. You can measure it. A typical U-cup has 3 measurements. It's the inside diameter of the seal, which is, you'll measure the rod for that. The outside diameter of the seal, which the easiest way to get that is to measure the thickness of the seal. Let's say it's 1/8 times 2, which would be 1/4. So it's 1 inch rod, inch and a quarter. So it'd be 1 inch inside diameter, 1 and a quarter outside diameter. So times the height. That's how you measure the seal. Now, if it's a metric seal, in a lot of instances, part number is actually the measurement. So you got the rod seal, which has got a lip on the inside. You got a piston seal, like this could very well have a U-cup on it, and it'd have a lip on the outside. And there's a universal seal that's got lips on the inside and the outside, and they can be used either place. So in my business, I use the universal seals for everything, and that way I could keep a good inventory. And then there's something called a loaded U-cup, and this groove in the back of this U-cup, a loaded U-cup will have an O-ring pressed in there. It could be just a regular round O-ring, or it could be what they call a quad O-ring, which is O-ring with 4 sides, 4 corners to it. So almost like 4 teeny O-rings made into one. I almost always use loaded U-cups because that O-ring in there keeps pressure on the lips, and that helps reduce static leaks. A static leak is with the tractor shut off, there's no pressure pushing in this groove, so the seal will relax, and it's possible the hydraulic fluid can pass over the seal and just drip out. Now, a lot of times you'll see a tractor just got a little drip when it's parked. It works fine when it's running. So that's a static leak, and loaded U-cups help prevent static leaks. Okay, I'm going to get the piston seal out. Being that it's such a narrow hole, it's a little harder to dig the seal out. I'm going to take this O-ring pick, I'm going to jam it into the seal and twist it and try to get it to pop out. And I'll probably tear the seal up in the process. And this seal is not in too bad a shape. A lot of times a seal will be disintegrated, and you'll dig it out in little chunks and be like, oh my God, I can't measure the sucker. Because if you measure the seal, then you can take it down to a hydraulic shop and just buy universal seal. But a lot of times you'll find that you need to get a measurement when you don't have a good seal to measure off of. And that's kind of easy to do. And the key to that is Play-Doh. What you'll do there, you'll force some Play-Doh down into that groove. But then you can take your calipers and measure it. Measure the height, the thickness of the seal itself, times 2. And then you already know the inside diameter because you measured the rod. I've got this fancy little tool here. I'll show you how that works, and I may not be able to use it. You shove the seal up in there, and you twist it. It'll change the shape of the seal to where you can drop it in place and pull the tool out, and the seal will lock in place. But I never really use them, so I'm just showed you the tool. So you just take this and you kind of give it a little bit of a bend, and you just got to force it in place. Being it's such a small hole and a relatively large seal, sometimes you really got to fight with it. So you get it started and use a semi-blunt screwdriver with this, maybe a little sharper than what I like. And I'm going to get that sucker pushed into that groove. And I'm going to keep fighting it till it snaps in. And it will go, and I will get it, but I might turn the camera off and fight with this for a little while. Okay. I got the wiper and the seal in. I'm about to put the O-ring on the outside of the gland. Now I've got something I've noticed here, just by picking it up earlier, is that I'm pretty certain this is a 90 durometer O-ring, which means your typical O-ring is 70 durometers. It's softer. This one's a pretty hard O-ring. Why they're using that, I don't know, but I'm going to go ahead and use it. 90 durometer O-rings are usually used in places on O-ring boss fittings and stuff where you run the risk of damaging the O-ring, or what happens is O-ring boss is a fitting. This is an O-ring boss fitting that I dug up out of my junk drawer, so forgive it for being so filthy. O-ring boss has a straight cut thread with an O-ring followed by a flat washer and an adjustable nut. You thread the fitting in to its bore until the O-ring starts into a chamfer in the bore. Then you align your fitting in the direction it needs to go, and you finish tightening it up using the nut. This is a 90 durometer O-ring that is used on O-ring boss fittings. Durometer is a method of measuring the hardness of the O-ring. 90 durometer is harder than the typical O-ring, which is 70 durometer. If you use a 70 durometer O-ring, you run the risk of this O-ring pressing out of the chamfer and past the washer, causing a leak as the spinning motion of the nut tries to turn the O-ring. Also, this particular fitting has a JIC into it. JIC uses a 37-degree flare as opposed to an SAE flare, which is 45 degrees. JICs are mostly used in hydraulics, where SAEs are used in lower pressure gases. JICs are always steel. SAEs can be brass, and you don't want to use brass on a hydraulic system. JIC stands for Joint Industrial Council. You do not use any Teflon tape or thread sealing tape or thread sealing goop of any kind on a flare fitting, nor would you use it on the O-ring boss fitting. Flare fittings will have a torque. It is be a really good idea to torque it to the proper specification, because chances are if you over torque it, it will wind up leaking. Okay, I'm reassembling it. When you reassemble it, wipe a little oil on the seals and on the rod. There's the gland back in place. Put the piston on. I'll look and I'll see which end may have obviously had, I can see the hex for the nut on that end. Really doesn't matter on this one, I don't think, because the pressure goes in two different directions. So, work that piston in. Kind of rocking it back and forth, letting the air escape past that seal, since I didn't get that inner line off. And tell you what I'll do, I'll go ahead and get this pin back in as soon as I can, which I could have already. Pulled out a little bit. Okay, there's the pin. I need to go ahead and put the cotter key in. I'm going to do that before I go any further, because when I put a pin in that needs a cotter key, I like to put the cotter key in right away. Alright, that should be good. Start the gland in. And I got new set screws. It's done. Hopefully, like I said, it will seal okay. I'll go through 5 gallons of transmission fluid or hydraulic fluid, which in this machine, the hydraulics and transmission share the same fluid. So how do you know if a hydraulic system is running hot? Now, on your typical old school systems, this is just rule of thumb, it's not written in stone anywhere, but if you can lay your hand on the reservoir and it's uncomfortable to keep your hand there, but you can keep your hand there, you're probably a good temperature. If it's so scalding hot you can't do that, well then you're running hot. Now some fluids may run hotter these days with the hydrostatic transmissions and all. Just do a little research on that. I'm going to tighten this up and put the pin in, then I'm done. I want to thank you for watching my video. Stick with me, and remember, if you love life and learning new things, go aimless.com.